Thinking about movies like Interstellar.
Sure.
That scene on Miller's planet.
Oh, yeah. Right next to the black hole, Gargantua.
Exactly.
Mm.
Where, like, minutes for them on the surface turned into, what, 23 years for the guy left on the ship?
That's the one. It's incredibly dramatic. Really sticks with you.
It really does. But it always makes me wonder, is that just, Hollywood exaggeration? Or is there some real science to that kind of crazy time difference?
Well, it's a great question. And actually, while movies always take liberties, that core idea, it's definitely not just fiction.
Oh, really?
Yeah, it touches on a very real scientific phenomenon. It's called time dilation.
Time dilation. Okay. So not just made up. Where does that idea come from? Is it new?
Not at all, actually. It's a fundamental part of Einstein's theory of relativity. Been around for over a century.
Einstein. Right. So what's the basic idea? How does it work?
Well, in simple terms, the stronger the gravity you're experiencing, the slower time passes for you compared to someone who's in a weaker gravitational field, like further away.
So gravity actually slows down time.
Effectively, yes. You can sort of picture gravity as warping or stretching the fabric of space-time itself, and time is part of that fabric.
Wow. Okay. Gravity messing with time. That's hard to wrap your head around.
It is a bit counterintuitive to our everyday experience, definitely.
And I guess black holes must be the most extreme examples of this, right? Because of their insane gravity.
Exactly. They're the ultimate example. You've got this enormous amount of mass crushed into an incredibly small space.
Right.
That creates a gravitational field that's just unbelievably intense, and it causes a really severe warping of space-time right around it.
Okay. Let me try to picture this. So say you have someone, I don't know, orbiting near a black hole.
Uh-huh. Bravely, I might add.
Right. And someone else is way out, maybe back here on Earth.
Okay.
If only a few hours pass for the person near the black hole, could that really be like years for the person on Earth?
Yes, precisely. The difference in how time flows becomes much, much more pronounced as that gravitational field gets stronger. So yeah, a short trip near a black hole, time-wise, could absolutely correspond to many, many years passing for someone far away in weaker gravity.
So back to Interstellar then. They threw out a specific number, didn't they? 1 hour on that planet.
Yeah, they said 1 hour equaled 7 years back on Earth, or further away from Gargantua at least.
7 years? Is that specific number plausible? Or is that the movie magic part?
Well, look, getting that exact ratio, 1 hour to 7 years, would require some very, very specific and, frankly, extreme conditions.
Yeah.
You'd have to be orbiting incredibly close to a rapidly spinning black hole.
Sure.
So the number itself probably amplified for dramatic effect.
Okay, that makes sense.
And this is the key thing, the underlying principle. That gravity causes time dilation, and that it could be that significant near a black hole. That's absolutely solid science.
Right. They didn't just pull it out of thin air.
Not at all. In fact, the filmmakers actually worked closely with Dr. Kip Thorne.
The Nobel Prize winner.
That's him. A leading expert on relativity and black holes. They wanted to get the science, as right as they reasonably could within a movie context.
Wow. So the core idea, these huge time differences near black holes, it's not just a plot device. That's genuinely mind-blowing when you think about it.
It really is.
Imagine, if we ever developed the tech to safely get close to one. You could take a trip, come back, and find everyone you knew had aged decades or centuries maybe. Well, you'd barely aged at all.
It's one of the most profound and frankly weirdest implications of the laws governing our universe. It sounds like pure fantasy, but it's a natural consequence of how gravity and time are linked.
So this isn't just some abstract theory or cool movie idea. This time dilation effect, it's like really happening out there around actual black holes.
No, absolutely. It's a fundamental feature of reality. It's woven into the very fabric of space-time. We just haven't, gone there to experience it ourselves yet, but it's out there.
It just shows how much we still have to learn, doesn't it?
Yeah.
About the universe.
Definitely. It's incredibly complex.
Because space seems like the more we look, the deeper and weirder it gets.
Couldn't have said it better myself. There's always more to discover.